Students, so in this question you're given that f of x, the function, is mod x minus 2 plus mod x minus 5. You're asked in the first statement if you're given that f dash of 4 is equal to 0. And the second statement is f of x is continuous in closed 2, 5, differentiable in open 2, 5, and f of 2 is equal to f of 5. So let us take the first, let us try to analyze the function first. So what is mod x minus 2 plus mod x minus 5? How do you analyze this function? This is a modulus function. So you have two mods. So the modulus function, whenever you have function having modulus, we analyze it by the method of intervals. So method of intervals, MY. So first we take individual mod expression. So what is inside the first mod, x minus 2? So when is this expression is equal to 0? X is equal to 2. And when is this expression is equal to 0? X is equal to 5. So those points are called critical points. So what are the critical points? X is equal to 2, 5. So critical points are the points where the expressions inside mod is equal to 0. So once you have the critical points, you just need to divide the real line or the domain into intervals. So the domain is divided into 3 intervals, that is less than 2, between 2 and 5, greater than 5. So you divide the real line into 3 intervals using these two critical points. Now you need to analyze the function separately in these 3 intervals. So when x is less than 2, x minus 2 is negative, x minus 5 is also negative. When x is less than 2, this is also negative, this is also negative. So what does mod do? So mod of x minus 2 becomes 2 minus x, right? If the expression inside mod is negative, mod will add one more minus. So in this interval x less than 2, the function is 2 minus x plus 5 minus x, that is 7 minus 2x. So the function is 7 minus 2x, right? And between 2 and 5, if x is greater than 2 and less than 5, x minus 2 is positive, x minus 5 is negative, right? If you take a number 3, for example. So 3 minus 2 is positive, but 3 minus 5 is negative. So because x minus 2 is positive, mod x minus 2 is x minus 2. Because x minus 5 is negative, mod x minus 5 is 5 minus x. So if you add these two, you get 3 as the answer. That means the value of the function between 2 and 5 is always equal to 3. Now if you go to the interval greater than 5, this is also positive, this is also positive. So I can remove mod, So the function will be 2x minus 7. 2x minus 7. So before x is equal to 2, the graph corresponds to 7 minus 2x. That is a decreasing graph. It is a decreasing graph. Between 2 and 5, the graph is always equal to 3. Always equal to 3 is a constant graph. And after x is equal to 5, it is an increasing graph 2x minus 7. So now this is the graph of f of x. Now let us analyze this given statements. The first statement is f dash of 4 is equal to 0 and x is equal to 4. Because it is a constant function between 2 and 5, f dash of 4 is equal to 0 is right. Next statement 2, f of x is continuous in 2, 5, right? So between close 2, 5 it is continuous. And in open 2, 5 it is differentiable, which is also right. And f of 2 is equal to f of 5, which is also right. So statement 2 is also right. So statement 1 is true, statement 2 is true, but statement 2 does not explain statement 1. Because this is happening, f dash of 4 is not equal to 0. F dash of 4 is equal to 0 because this is a constant function between 2 and 5. So the answer should be S1 and S2 are true, but S2 is not a correct explanation for S1. Thank you.